Hello, this is Mrs. Boots, and before we start solving systems by graphing, we're going to review how to graph a straight line. This is a concept that was covered in Algebra 1 for quite some many lessons there, but we are going to go through it just to make sure we remember it, all right? So we have the basic form of a linear equation, y equals mx plus b. The question then becomes, what do I do with this to get it on a graph, okay? So let's look at the pieces, right? B is my beginning point. Specifically, it is the y-intercept. Now, B is always a constant. It doesn't have an x with it. It can come at the beginning of the equation. It can come at the end of the equation. It's not multiplying anything, all right? So B is just a constant, just a number being added or subtracted. And that's it, just a number, all right? The next piece to our equation that helps us graph is the m value. M is the slope, right? And if you remember slope is an equation which was rise over run. Now remember, rise, that's your y, run is your x. So rise, that's how high I'm going, x is how far across I'm going. So m is typically a fraction. If it's not a fraction, we just put it over 1 and we go with it, okay? So we have one example that we're going to do as a review, and then we'll move on into our systems. Okay, so for b, in our example equation, which number is the b? I need a number that's by itself. No x, no multiplication, no nothing, just adding or subtracting of that number. Yes, it is the 5. And yes, it normally comes at the end. So what we're going to do is we're going to take that 5 and we're going to put it on the y-axis. So we have to count up 1, 2, 3, 4, 5. And put a big beautiful dot there. Okay, now I need my slope. The slope is always attached to the x. It may be a fraction, it may be a whole number, but it's always the number in front of the x. So the 1/2 is the number in front of the x. So that is my slope, right? So remember, it's rise over run. That means I'm going to go up 1 and to the right 2. If it was negative, I'd go down 1 and to the right 2. We only change one of them, okay? So I'm going to go up 1 and to the right 2. And then up 1 and to the right 2. I can go down 1 and to the left 2 because I changed the direction of both of them. Change the sign of both of them. All right? This gives us a nice, pretty, straight line. Okay? And if you can draw it through all the dots, that is preferred. If you need a ruler, that's awesome. Okay? It doesn't matter. When we're doing graphing of systems to solve, we need to make sure that our lines are very, very straight because where they intersect is going to be our solution. And this is our review for graphing lines, and now we will proceed with solving systems by graphing. Hello, this is Mrs. Boots, and this is our lesson on solving systems by graphing. Now, a system, what is a system, right? We're not talking about the solar system where we have planets rotating around. A system is a system of equations for mathematics. Now, in reality, we do have equations that tell us about the orbital patterns of each planet, as well as their rotation on their axis. So you could say it's the same thing, but not really, all right? So with a system of equations, you have more than one equation with more than one variable. Typically, you're going to have the same number of equations and variables. And the reason you need that is so you can actually solve it. If you don't have the same number, you can't necessarily solve it, okay? So if you'll notice in example 1, we have two variables. We have an x and we have a y. There's our two variables. And we have two equations. Now in solving by graphing, remember the y has to be by itself. So I need y equals blah, all right? So I got y equals blah and y equals blah. The blah is the rest of the equation, whatever that equation could be. All right, it could be a linear, it could be a quadratic, it could be a cubic, it could be any of the parent functions. But for this particular lesson, we're going to take it super simple. We're just going to do some linears. We might throw a couple of simple quadratics, see if you can figure those out, but it's not that big of a deal. Okay, so first thing, remember how to graph your lines. We have to find b. We're going to do one equation at a time, and I am going to color code it. So the first equation is going to be a beautiful blue. If that's not blue to you, don't worry about it. I need my b. Remember, b is the constant. By itself has no x's, has no y's. So in this case, it is -3. So I'm going to go to my graph. 1, 2, 3. Boom. There's a big, beautiful blue dot. And now I need my slope. And this is where some students panic, right? There's nothing in front of that x. Well, if there's nothing in front, it's 1 over 1, right? So I'm going to go up 1 and over 1, up 1, over 1, up 1, over 1, okay? So I have a big, beautiful blue line. Up 1 and over 1, all the way across. That's easy enough, right? We just graph a line. No big deal. Well, now we have a second line. I need another graph. No. We're going to put that line on the exact same graph. That way we can figure out exactly where they cross, okay? Because where they cross, where they intersect, that's my solution. If you remember back to our example where I've got the cost, right? And I start with some amount that I've borrowed from the bank, and I'm slowly eating away at that, right? And I've got my profit line. And where my profit and my cost line intersect, that intersection point is the place where I break even. I now I'm not borrowing from the bank. I'm actually making money, right? And so I'm getting a profit from this. And that's a good thing because we all like a little bit of profit, right? And it also, for business, that means you're not going to end up closing your doors, which is awesome. So let's do the second line. Let's figure out what's going on. So my b, what is b? b is -1. So we go down 1, we put a big, in this case it's a purplish color, dot. Okay, so I put my dot, and now I need my slope. The slope for this one is a negative sign. That means -1 over 1, right? -1 over 1. So I'm going to go down 1 and over 1, down 1 over 1. We're going to draw that big, beautiful line in. Okay. Now we have a point of intersection. Remember, the point of intersection is the solution. And that solution is right here where my two lines cross. In this case, the x value is 1 and the y value is -2. Now, what those numbers mean in a business perspective depends on the business, depends on the products, depends on what X and Y represent. And that's getting into word problems, so we'll do that another time. Okay, so now what type of solution is this? Well, that's the cool part. All right, the type is actually called independent. Because the two lines are completely independent of each other and they cross at one point. Now, obviously, if I've got a parabola U-shape, it's going to cross at 2 points, right? If I have a cube, it could cross at 2 or 3 points. So it depends on what we're graphing as to how many solutions we're going to have. But if I've got at least one unique solution, which means an x and y coordinate pair, then the system is considered to be independent. All right? Let's look at example 2. Same thing. I'm going to draw a graph. In fact, we even used one of the exact same equations. Oh no, not the exact same equation, but very similar. Okay, so we're going to do our first line. B is -1. Put in -1, nice big pretty dot. Slope is 1 over 1. We were real creative on these examples, right? So we're going to go up 1 and over 1. Up 1 over 1. We're going to draw a nice pretty line going through there and hopefully hit all the dots. I'm a little bit off, which may affect my answer, so I've got to be careful. Okay? Second line. Remember, you have to graph both of them to find the solution. This one, the y value is up 2. So I go up 2 on my graph, put my dot. Okay? Now let's do our slope. Slope is 1 over 1 because there's nothing in front of x. So I go up 1 and over 1, up 1 and over 1. We have a problem. Do those two lines cross? They don't cross. Mrs. Boots, I did it wrong. No, you did it right. What kind of lines are those? What do we call those again? It has a fancy word. Starts with a P, and it's not problem, it's... Yes, they're parallel. They're like railroad tracks. We don't want them to cross. We want them to stay the exact same distance apart all the way down the line. And if they're not, we're going to have a problem. Now, the way I drew it on the board, one line's slightly crooked. And that's my bad. That's my lack of artistic ability. Oops. Okay? But they're parallel lines. If it's parallel, they're never going to cross. If they're not going to cross, that is a no solution. Okay? If they never cross, it's a no solution. They're parallel lines. That means the type is inconsistent. I have an inconsistent system. Okay? An inconsistent system has no solution. Now, most of the time we don't refer to the types. Most of the time we refer to what is the graph look like and what is the solution. So perhaps over here on example 1, we should go back and write intersecting, if I can spell intersecting today. There we go. Because these are intersecting lines, these are parallel lines, okay? If they're intersecting, I have at least one unique solution. Parallel lines, no solution. So if I graphed it and I was asked what the solution was, boom, that's it. There is none, okay? So if it's a multiple choice, it's no solution. That should be one of our choices, all right? Let's look at the last example, okay? Oh, slope's not 1. Yay, okay? Let's look at it. First one, we're going to do it in blue just like we have the others. So first thing I need is my y-intercept, my beginning point, my b, which is -1. So I'm going to go down 1, put a big old dot. It's nice, big, and beautiful. And then I look at my slope. My slope is 2. Well, I need a fraction, right? So remember, whole numbers, you can always put them over 1. So it's always 2 over 1. So I'm going to go up 2, 1, 2, over 1. Put a dot. Up 2, over 1. Okay? Draw that big, well, maybe draw the big, beautiful line in there. Try and draw it straight. Don't do like Mrs. Boots on the whiteboard and draw it crooked. It doesn't help you much. Okay, so now we gotta look at the second line. Here's the problem. That second equation, is it in y equals? Does it say y equals blah? No. So I have to get it in y equals, okay? So we're going to come over here, off to the side, and we're going to have to solve that for y equals. Okay, so the first thing you have to do is move the x. So I'm going to have -2y equals -4x plus 2, because I got to move the x over. So now we're closer. Y is almost by itself. We have to divide everything by -2. So I end up with y equals 2x minus 1. Okay? So I have y equals blah. It's beautiful. So now let's find our b. b is -1. Cool. I've already got a dot on -1. Then I'm going to go up 2 and over 1. So I go up 2 over, What does that mean? Mrs. Boots, come on, it's the exact same equation. Yeah, it's the same equation, which means it's the same line. So where do they intersect if it's the same line? Well, they're right on top of each other, right? One on top of the other. That means that the solution is all real numbers. Every single point on those lines is a solution because every single point is a point of intersection, okay? This is what we call a dependent And if you're not sure, oh, gotta spell it right, sorry about that. If you're not sure what dependent means, you on your taxes. You don't file taxes, right? Well, maybe. Depends on if you got a job, right? Your parents file taxes, and on their taxes, you are a dependent. That means you live under their roof, you eat their food, they pay your bills, they clothe you. You are dependent, all right? If that doesn't work for you because maybe you're expected to pay your own clothes out of your job and blah, 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 okay, try this one, a newborn baby. Okay, a newborn baby is dependent, completely, 100% dependent for somebody to feed it, somebody to clothe it, somebody to burp it, to change its diaper, to keep it clean, to keep it healthy. All right, it's completely and totally dependent. So if it's the same lines, it's like mama and baby. Baby is dependent on mama, 100%. Okay, so those are our three types. So when we're solving any system, whether it's by graphing or by one of the other methods, which we will talk about in later lessons, you can have three different kinds of answers, three different kinds of solutions, right? We can have a specific solution, a coordinate point. We can have no solution, which means they don't touch. They're parallel lines. It's not happening, okay? No solution. Or everything can be a solution, all real numbers. Those are the three types of solutions you can get when graphing. This concludes our graphing notes. We actually have a couple more examples where we're going to check our answers and see if we can figure out if we got the right one. Hello, this is Mrs. Boots, and welcome back to the second part of our lesson on solving systems by graphing. In this particular lesson, we're going to try and figure out, is it a solution? So we get an answer, we get the problem, and we have to figure out, is that the right answer? It's really super easy, okay? Because all we're going to do is plug it in. Really? Yeah, we just plug it in. All right, so let's make a note. Plug in X and Y. All right, that's all we're going to do. We're going to plug in X and Y. Okay, so here's the funny part. This is the most common mistake, and you're going to laugh. You're really going to laugh. It's funny. Okay, which one's X and which one's Y? Okay, because that's where people make their mistakes. Okay, so in the coordinate pair, remember X is first. And you're probably rolling your eyes going, really, Mrs. Boots? Yeah. But the problem is people put the wrong number or the right number in the wrong spot. Okay, so let's just go through and underline, right? So the Y is 1, and those where my Y's are at in my equation. So when I plug it in, so we're going to do the first equation, and then we'll come down and we'll do the second equation, just because, kicks and giggles. We'll do them in order. So I'm going to plug in X, I'm plug in Y, and I'm going to see, is it equal to 6? That's the question. Is it equal to 6? We're not actually solving it, okay? So let's look at the second one. The second one, I'm going to plug in X. I'm going to plug in Y and ask, is it equal to 3? Okay? Really super simple. Is it equal to the 3? Okay? So I'm plugging my X's. X is what? 4. 4. Okay, so there's an X here. I plug in a 4. There's an X here. I plug in a 4. Easy enough, right? Y is what? 1. So plug in 1 here. Plug in 1 here. Okay? Now we're actually going to go through and do it. Okay? I have 4 plus 2 times 1. What is 2 times 1? 2. Okay, so what's 4 plus 2? It is 6. So I get 6 equals to 6. That's a check. I have the 6 on both sides. That means it works for that equation. That's good, okay? But it has to work for both equations. If it doesn't work for both equations, it's not a solution. Okay, so second one, I have 4 minus 1 equals 3. So 4 minus 1, what's 4 minus 1? So I have 3 equals to 3. Because 4 minus 1 is 3, and the other side was a 3. So that checks. So if both of them check, then yes, it is a solution. Okay? They both have to check. Now, one of them may not check. And if one of them doesn't check, it's not a solution. Okay? Let's look at the second example. Okay, so I'm going to write out my equations. I'm just going to put parentheses in there. See if we can figure it out. First equation. Parenthesis equals negative parenthesis plus 4. I got to plug stuff in, right? Second equation. Parenthesis equals parenthesis minus 1. All right? Now, what is this letter? It's a Y. Which number is the Y? Yeah, it's the 1. Okay? So I'm going to plug in a 1 for my Y's. Now the problem is we're so used to going in order with the X's first is that some people will plug in the 2 and then they're going to get it in the wrong spot. 2 is the X. So we plug it in 2, both places. All right, now let's figure it out. Let's see if it works. All right, so I have 1. Oh, that's easy enough. Negative 2 plus 4. What's negative 2 plus 4? Well, that's 2. Is 1 equal to 2? No. That one does not check. Let's just go ahead and check the second one for kicks and giggles. I have 1 equals to 2 minus 1, which is a 1. So this one does check. But because the first one didn't check, remember they both have to check, the answer for this would be no. It is not a solution. So anytime I'm checking to see if something's a solution, we plug in X and Y. The only trick is to make sure we plug it in the right place. So plug X in for X's, Y's in for Y's. Don't mix them up. Well, that's easy enough, but we're all going to make that mistake. We all do it, okay? I've done it on the board in front of the students. It's embarrassing, but in any case, okay? Then they both have to check, both equations. If there's 3 equations, guess how many have to check? All 3 of them. If there's 5, how many have to check? All 5 of them. It's just really interesting how that works. If they all check, it's a yes. It is a solution. If they don't check, no. Doesn't matter if all or none, okay? If some or few or most, doesn't matter. If any one of them does not check, the answer is no. Okay, so please go ahead and start your practice for graphing, solving systems by graphing. Thank you very much.